consider a parallel plate capacitor and find out the formula or the dependence of a capacitance of a capacitor on its dimensions of shape, size and the distance between the parallel plates which we have considered for a capacitor. Here we are now going to the region 3, that is the center between the plates. Fine. Okay. So now what can we write for E1? E1 is equal to sigma upon 2 epsilon naught. E2 is also sigma upon 2 epsilon naught, that we already know, but we have to now find out the direction of E1 and E2 at a point, say R, between the plates. So for E1 towards the point, from positive charge towards the point, E2 from the point towards the negative charge, so E2. So as you can see, the directions are same from conductor 1 to conductor 2. So what should I do here? E is equal to E1 plus E2 by principle of superposition. Their magnitudes have to be added up because the directions of E1 and E2 are same. So sigma upon epsilon naught is the electric field between the two plates. Fine. Okay. Now sigma is equal to surface charge densities Q upon A. So just substitute it in E is equal to sigma upon epsilon naught. We get Q upon A epsilon naught. Let us name this as equation 1. Yes. Okay. Now we also know, and what is its direction from plate 1 to the plate 2? That is its direction. Okay. Then V is equal to ED. The potential formula which we have already derived in this chapter only, V is equal to ED. Now E I have got, so let me substitute E in this equation. V is equal to ED. We get V is equal to Q upon A epsilon naught D, where E I have substituted as Q upon A epsilon naught and D I have written as it is. So this is the equation number 2. Now in the previous page we have learned the formula of the capacitance C is equal to Q upon V. Substituting the equation 2 in the denominator, we write its reciprocal, Q multiplied by A epsilon naught by QD, where Q cancels, and we get capacitance C is equal to A epsilon naught upon D.